we're going to talk a little bit about all these things. Electrolytes, just a little bit of review. Solubility, basically. Solubility, something called solubility equilibrium, which I think we've touched on briefly. Solubility and temperature and solubility and pressure and how those things all affect each other. First things first, electrolytes. You guys know what electrolytes are. You should know the definition, right? They are solutions that conduct electrical current, right? Why? Because they usually have positive and negatives, right? Which ones are strong electrolytes again? Do you remember? Strong electrolytes. What are they? Strong, yep. Partially maybe, but you have to tell me the other part that goes with it. Strong electrolytes. Sodium chloride would be one. Generally speaking, what are they? Ionic, very soluble ionic compounds, yes. Like sodium chloride, sodium fluoride would be okay. Very soluble ionic compounds, right? What's another strong electrolyte? What's the other one? Yep. What kind? Yes. What are those called? Acid. What kind of strong? What kind of strong acids are good electrolytes? Strong acids. All right. I ruined it. Great. It happens. Strong acids are also good electrolytes, right? You get a lot of ions, and the more ions you have, the more plus minus, the more electrolytes you're going to have, right? The more conductive it becomes. So when we talk about electrolytes, we're talking about ions, right, in a solution. What are those ions? I used it in sports drinks just because, I'm not saying go drink sports drinks, but I just used it because that's what we know, I think. Most of us know what sports drink, Gatorade, Powerade, most of us have had those, okay? When you think about sports drinks, look at the first two ingredients in sports drink. The very first one is going to be probably potassium. It says potassium, but guess what? It's not potassium. It's probably potassium ions, okay? What is that with? What is the potassium ion? There we go. What is the potassium ions with? Well, whatever else is soluble. So, for example, maybe it's potassium chloride, potassium nitrate in some cases. Probably not those. It's probably one that, of course, would be very safe for you, et cetera, et cetera. How do you get the K plus? Well, you have to have the negative part that goes with it. That plus and minus that you drink is helping you, right, have more pluses and minuses in your body, electrolytes, okay? The other thing that that you need as well, of course, not just sodium. Also, you can look at sodium, sometimes potassium, calcium. Those are all possibilities, but you also need sugar for your body, okay? Sports drinks, the reason that they're around, I guess, if you want to say, is because you have water solution, which you need. They have electrolytes in them, and they also give you energy through sugar. The first three ingredients here, there is no fat. That's probably good, because that'd be gross. Sodium, 115 milligrams of sodium. So in this particular case here, they're using sodium, probably sodium chloride or salt, okay? Sodium ions, or maybe some other type of sodium chloride, or sodium, I don't know. Sodium, potassium are the first two labeled on here, other than fat, which I don't even know, because I thought you had to go in order. Anyway, sodium, 115 milligrams, potassium, 30 milligrams, okay, are the first two things labeled on here. And then the last one here is carbohydrates, 5 grams. What is carbohydrates? That is carbons, hydrogens, and oxygens, aka sugar, okay? It says right here, sugars, 5 grams of sugar, okay? That's a little bit a lot, okay? And you can measure it out. I've done it before. It's a lot, okay? So those are all parts of this that you will use that you have in sports drinks, okay? But that's what they're designed to do. They're designed to give you water solution, okay? Electrolytes? No, can't have it back. Electrolytes, okay, and things like that. And what do those things do? They help for muscle contraction, nerve conduction, waste removal, blood pressure maintenance, and many other functions as well, okay? And I'm not saying you know, like I said, I'm not saying go drink sports drinks because they're actually, in some cases, they're not overly great for you because they do have a lot of sugar. But that's kind of what their purpose is. I drink them once in a while too, especially after hockey. I've got nothing else to do. Three other terms that you need to know here. Saturated solution, okay? Saturated solution, notice the definition. You might say, I know what it is, but think of it this way. It's the maximum amount of solid that you can put into a solution at a given temperature so that there is no undissolved solid, okay? So in other words, there is no extra undissolved solid. It is the absolute maximum for that particular temperature, okay? And yes, we can change that, okay, by heating it up or cooling it down, but that's why the temperature thing is there. Unsaturated solution is, of course, what it sounds like. We could probably fit more solid into there at that temperature if we had to. So it's unsaturated solution, okay? And finally, supersaturated. We're going to talk a little bit about this. How do you get a supersaturated solution? It actually contains more solid than what you're supposed to at that temperature, okay, at a given temperature. We can do that through a few ways, which we'll talk about, but supersaturated basically means it's oversaturated, okay? It holds more than what it's supposed to. We are going to do this for you. Now, how well this turns out usually takes quite some time for this to happen, but I'm going to show you this solubility equilibria. If you take, I'm just going to simplify this for you. I don't even know, they don't have a, I think they use copper 2 sulfate, if I'm mistaken. Yeah. So whatever, it doesn't matter. If you take it on a compound, like for example, copper 2 sulfate, and we place that into water. Copper 2 sulfate is not very soluble, so that's usually what it works best with. It'll float to the bottom and sink there, okay? So you'll see a bunch of copper 2 sulfate down here initially. What you have to understand is that there's always an equilibrium going on in here. There's always ions. There's two ions here. There's copper 2 ions and sulfate ions, and they are in constant equilibrium. So at some point in time, one of these solids here is going to break up into copper 2+ ions and sulfate ions, okay, floating around in that solution. So you will get some of this. Remember the analogy? I said out of about 100, and this is not the right numbers, but out of 100, 1 would be in the ion form, 99 would be in solid form, okay? But it's not just that one that stays all by itself and never does anything else. Those eventually will come together and form a solid, okay? And a solid will eventually break up into ions. And that process continues. You can't see that happening, of course, because it happens simultaneously. And what you notice is in saturated solutions, or oversaturated solutions is what we're going to do here, what you notice over time is that it actually changes form. So you might get a very powdery copper 2 sulfate to start with, very powdery, very, in some cases very light. And over time, as that process goes through, as it keeps going and going, if you think about ionic compounds, you think about plus, minus, plus, minus, plus, minus, plus, minus. That's actually what the structure looks like after a while. It gets to be very crystalline, very kind of, layered kind of structure, and it changes into that over time, and you can actually see that. It's kind of neat, actually. So we'll do that tomorrow. I'll start that tomorrow when we're in the lab here, and we'll keep it over here somewhere, and we'll check in on it every day. We'll do the solubility equilibrium check every day. It's going to take a while, so we'll have to be patient, all right? All right? But that's what happens in a solubility equilibrium. And when we have that, sometimes we say, hey, you know what? This process goes back and forth. So we say, yes, it breaks up into copper 2+ and sulfate ions, but those also reverse and change back into copper 2 sulfate as well. And this is very, very prevalent with slightly soluble ionic compounds, so bottom row types of compounds on the solubility chart. All right. Last things last here, temperature and solubility. How does temperature affect the solubility of these three states here? We're obviously talking about solids in solutions. Okay. So we're talking about in water, for example. Okay. It may not be water, but let's just pretend it is, just for simplicity's sake so we don't get too confused here. If you take a solid and you put it into water, and let's say you have it saturated, all right, or maybe even oversaturated or supersaturated. If you heat up the water, okay, if you heat up the water gets more space in between them because you're breaking some of those hydrogen to hydrogen bonds. And because there's more space between the waters, you can fit more solids into those spaces. So you can get a higher concentration, okay, by heating up a solution. So if you increase the temperature, if the temperature increases, the solubility of a solid increases. Okay? Which means basically as a result of that, you could say concentration increases. Yes? Okay? The more solid you can fit into a given volume of water, the more concentrated it's going to be. Okay? If you do that with a liquid, so let's say, we'll just say, we talked about bromine, for example. If you heat up bromine in water, what happens? And the answer is, well, they're both liquids already. So if you increase the temperature, okay, the solubility is unaffected. In other words, it's already a liquid in a liquid. You're not going to get more liquid into the spaces. Okay? The solubility is really generally unaffected. Okay? Not greatly. We're just going to say, you know what, it's not affected. Not to the same degree that a solid is, for example. Concentration, therefore, would remain same. Oops, that's in the wrong spot, isn't it? Let's move that there. In gases, if we talk about gases in a solution, I'm going to move this one down here. I guess, yeah, well, it's kind of, that's not really the wrong spot. Let me just finish this here, guys. If we talk about gases in a solution, well, if you increase the temperature, the first thing that's going to happen is the gases will try to escape. So solubility of gases in a solution, the solubility actually goes down. Okay? Because gases will try to escape because they're already boiled. They're already in gas form. You give them enough energy, they will try to leave the solution. And therefore, concentration actually will go down in that case. Okay? So that's what we need to be aware of with that. And the last thing here, real quick, pressure and solubility. Pressure has no effect on solids or liquids, but if you increase the pressure, okay, for a gas, for gases, the concentration will increase. You can force more gas into the solution if you increase the pressure. Okay? So if you basically push on the outside, if you keep pushing, you can fit more and more and more gas into that solution. Okay? We're not talking about pressing on the solution. That doesn't make sense. But pressing above the solution. If the solution's here, we're pushing more and more gas in. The more gas you can push in, the more concentrated it becomes. Concentration goes up, pressure goes up. Okay?